Hey there, this is the review on half-lives and carbon dating. So basically just a couple types of questions we'll go over for the carbon dating so that you can calculate either how old something is based on the amount left or based on how old it is, how much is left. But it's the same question, you're working in both directions. Um, this picture is the unfrozen caveman lawyer from, I think, like Swiss Alps or somewhere around there. Just because I talked about him in class and people looked at me like they didn't know what I was talking about. So that's him, kind of mummified by the ice. On a personal note for today's video, this mainly for people who do not know me or for classes in future years. When I have this video and you're like, did Mr. Kern used to be a rock star? No, it's actually wacky outfit day. I haven't dressed like this since the late 90s when it was marginally acceptable. So that's the reason for all this. I know better now. But I was in high school when I got it. We make bad decisions in high school sometimes. Alright, so first off, if you go here or just Google carbon dating animation, you can go to this. I'm sure I can't legally bring it up and show you what it is, but go there. It's just a quick review on the basics on the decay and how it's helpful for figuring out when fossils died, or if you have two things you dig up, which one died first. Yeah, so just a good thing for me to look at. Alright, so start off by just looking at questions out of the book. So, a couple ways to look at it. Just go to question 11 here. What fraction of the original amount would be in a wooden axe handle that was 190 years old? So actually, maybe first off, let's look at 9. Again, just to kind of review. Following items found on an ancient campsite: an axe with a stone blade, a wooden handle, a clay pot, ashes of a campfire, jawbone of a deer, an arrowhead. Which ones could be determined, or could use to determine the age of the site? So the idea is living things taking carbon. Some of that carbon's radioactive. When it breaks down, you can tell how much is left. So we have to look at things that were alive. Stone blade, not alive. Wooden handle, alive. Clay pot, not alive. Campfire, made out of firewood, that was alive. Jawbone of a deer, alive. Arrowhead, not alive. So it's based on the amount of radioactive carbon-14 that you took in your life, and then how much is left after you die. So all these questions, the number one step is how many half-lives, or how many generations. Okay. Then it's basically the generations times the time is how you figure out a lot of them. So if we're working with carbon-14, we know the half-life of carbon-14 is basically it's about 5,700. I think we've been using 5,720 years. But either way, you need to figure out how many half-lives. So, if they say it is 17,190 years old, you have to figure out how many half-lives. So, this is where you pause, see if you can figure out how many half-lives it went through, and then start, see if you're right. Or you could just work the whole thing right now and see if you can get all the way from beginning to end and get the right answer. So to calculate this, you need to take the time divided by the time for a half-life. A gets about 3 half-lives. So if you're 3 half-lives, the first one, you decay, half of the original amount is all that's left. After the second half-life, half of that amount is left. After the third half-life, half of that amount is left. Or it's 1 over 2 to the third is the amount. 2 to the third is 8. So the answer to that one would be C. 1/8 is what's left. Alright, so new question. The half-life, the time for half-life decay of palladium-234 is 1.2 minutes. So, what is the, let's go, percent, what is the percent left after, I don't know, 10 minutes? So again, hit pause now, see if you can do it, or wait till I get it set up a little bit and figure that out. Go back to the last one also, see how that one was done. This one's done the same way. So, the big question is how many half-lives? You have to figure out how many half-lives in order to be able to do anything on these. So, how many half-lives? If you go 10 minutes, divided by the time for every half-life, so 10 divided by the half-life time, you get 8.3 half-lives. Now, for most of the things we've been doing, we've been using whole numbers, so 8 decays. Although, if you do the amount left being 1 over 2 to the 8.3, you can actually get an answer. But for us, we can just more estimate it as a half, and then see how many, I guess, see what the fraction is once you've done 8 decays. So, a half, a fourth, an eighth, 16, 32, 64, and on for a little bit while I pause. So keep going, 8 generations, 8 half-lives, it's 256. It's 1/256th. So that's the fraction you have left. Ask for the percent. If I said what's the percent if you have a half left, you take 1 divided by 2 equals 0.5. You turn that into 50%. So if I say what's the percent left after this fraction, it's the same math. You take 1 divided by, instead of 2, 1 divided by 256. That equals 0.0039. Turn that into a percent, so that would be 0.39%. So that's how much you could expect to have of the radioactive element after 10 minutes. Now, one thing that maybe I didn't hit, or it's kind of a misconception maybe, is the idea that originally you have 100%. So let's say you have 100 grams. After one half-life, you do not have sitting on your table a half-empty package. You have 50 grams of the radioactive element, so let's just call that, let's go with uranium. 50 grams of uranium, but you still have 50 grams of whatever it decayed into. So maybe uranium would turn into thallium. The next half-life, half of that 50 grams decays, and then you're left with the rest of that being the thallium. And so it's not that half of the total weight just disappears, because that can't happen. Even if there are little pieces flying off, it's that half of the weight has now turned into the next state of decay. And so the next would be, well, whatever that element turns into. If it's alpha decay, it'll be 2 back. If it's beta decay, it'll be 1 forward. But that's a whole other video. But that's just one little misnomer. So like I said, there are 2 types of questions. There is the how much is left, in which case, step 1, figure out how many half-lives. Step 2, figure out the fraction. The fraction is 1 over 2 with the exponent of the number of half-lives, so it would be 1 over 2 to the 5 half-lives, if there are 5 of them. Or 1 over 2 times 1 over 2, so half times a half times a half. Do that 5 times, which in either case it is 1 over 32. That's how much is left. The other type of question is, how old is it? That's really the bigger one that we usually care about more, because that's, if we dig up our unfrozen caveman lawyer, what we want to find. Same first step, find the number of half-lives, Then just take the number of half-lives times the half-life time to get the age. So we have half-life of radon. My mind went blank suddenly. Radium 226 is 1600 years. So we originally had 100 grams of it. We end up only having 12.5, and the rest of it turns into radon 222. So step 1, just like you did last time. So see if you can work this guy out. If you need a little help at the beginning, you should realize 12.5 out of 100 equals 1/8. So from there, keep working your steps. So if 1/8 is the amount you have left, that is a half times a half times a half, or 1/2 to the third. So there are 3 half-lives to get that far. So to calculate the age, 3 half-lives times 1600 years per half-life gives me 4800 years. Alright, now one last thing that I don't think I hit really well is just to make the math easier, I gave you nice easy fractions. You have a half of it left, you have 25% of it left, or you have an eighth of it left, but you don't always have that much left. Because again, if you're looking for carbon dating, that's 5,700 years in between, so that's a lot of iffiness. So what they really do with it is they have this nice little graph where at any time, any amount that they find, they can figure out the age. So if you dig something up and it has 60% of its carbon left, you look on the graph, up 60%. So it would be maybe exactly like 5,700, or that's 5,600. If you dig it up and it has 20% left, 20%, that's about a fourth, so you can kind of estimate about what it would be. But the graph gives you a better idea. So it's not always nice, easy numbers like a half or a fourth, but if you have this graph, all you have to do is whatever the percent is, you find that on here, hit the curve, that would be the age. Other than that, that's about it. Same types of questions. The big key is how many half-lives, and then from there, your brain kind of does the math for you. So, you take care now.